The Lego is built. It's time for the next video. Are you sitting comfortably? But more importantly, can you see clearly? Then it's time for us to focus on the part of the electromagnetic spectrum that makes that possible. It's visible light. It was Isaac Newton who showed that light, or white light, is actually made up of different colours. He used a prism to disperse the light into the visible spectrum. He described 7 colours: red, orange, yellow, green, blue, indigo and violet. Even though he couldn't actually see 7, but he thought there was a mystical connection between the days of the week and the number of known planets at that time. The colour of visible light depends on its frequency. If the frequency is a bit longer than that of red light, we can't see it. It's infrared. If the frequency is just higher than the violet light, our eyes cannot detect it, and it's ultraviolet. Remember, as the frequency increases through the visible spectrum, the wavelength is decreasing because you have more waves per second at a higher frequency. Your eyes are actually more sensitive to some colours than others. A rainbow is a beautiful effect of the dispersion of visible light. Tiny water droplets in the air each act like a tiny prism in the bright sunlight. As the light travels through the droplet, each wavelength of light is slowed down, so you get refraction, but by different amounts for the different colours. Red light is slowed down the least and bent through the smallest angle. Violet is refracted through the biggest angle because it slows down the most. Under 20% of visible light is absorbed by the atmosphere, so light from the sun reaches us, and light that we emit can be seen from space. Light bulbs are useful. This is because they emit visible light, and we use this light to help us see. Another use of visible light is in optical fibers. I've mentioned these before in our infrared revision. They can be used in communications, but they can also be used in medicine to see inside your body without cutting you open. Cameras are another example of something that needs visible light. The lens focuses the light onto an electronic sensor, or a light-sensitive film if you're still old school. The aperture controls how much light gets in, and the shutter speed controls how long the sensor is exposed to the light for. So by changing the aperture and the shutter speed, you can capture more or less light for your photo. You might have thought Danger Mouse would not pop up in today's video. Visible light can't hurt you, can it? Visible light, particularly blue and violet light, can cause damage to the light-sensitive cells of your retina at the back of your eye. This increases the risk of vision loss over time. Very bright lights can damage our eyes, which is why you should never look directly into the sun. You would be putting a lot of energy onto a tiny area of your retina, and the retina doesn't have pain receptors, so you wouldn't feel the damage being done as you blind yourself. Join me next time as we move from visible light to ultraviolet, because you know that
regular review gets a better grade for you.
Don't forget to
Like,
so that I can keep making the videos.
comment,
Especially to request other revision topics.
subscribe.
So you can get notifications of when my next video gets uploaded.